It's kind of wild to think that tucked away inside almost every piece of software we use, our phones, our browsers, everything, is the DNA of a document written over 60 years ago. Today, we're going to unpack that document. It's called the ALGOL 60 report, and it's this quiet masterpiece that basically taught the world how to talk to computers.
So let's just start with the core problem they were trying to solve. Think about this question for a second. How do you write a set of instructions that's so crystal clear that any computer, no matter who made it or where it is, can understand it perfectly? That was the huge challenge back in the 1950s, and it's exactly what led to ALGOL. To really get why ALGOL was such a game changer, you have to picture the chaos that came before it. Seriously, it was like a digital Tower of Babel out there, a world with no common language. Imagine you have this amazing recipe, but every single time you share it, you have to completely rewrite it for each person's kitchen, using totally different words for bake, stir, or cup. That's literally what programming was like. An algorithm that worked on one machine was complete gibberish to another. It made sharing ideas almost impossible, and that really slowed things down. And this wasn't some small niche problem. It was a global headache. You had major computing groups in France, the UK, Germany, and the US all realizing that this lack of a standard was holding the entire field back. Everybody wanted a universal language. So, who do you call when you've got a problem this big? Well, you assemble a team of the smartest people you can find. Let's meet the architects of ALGOL 60.
Now, this didn't happen overnight. The whole journey started back in 1958 with a first draft that got everyone talking. Then came a series of meetings all over Europe and the US to hash things out and get everyone on the same page. It all came to a head at this one big conference in Paris in January of 1960.
So picture this: 13 representatives from 7 different countries all gathered together in Paris. For 6 straight days, they were locked in, debating and collaborating to create one single unified language, all based on a fresh new draft put together by Peter Nahr. And, this wasn't just some dry technical exercise. There was a real human story here. The report actually opens with a dedication to William Taransky. He was part of the American team, but was killed in an accident right before the conference. It's just this somber reminder of the personal passion that went into creating this thing. So, how did they actually pull it off? How do you create one language that's perfectly precise for a machine, but also easy enough for humans to use? Well, their solution was just brilliant. They didn't make one language. They made 3, all layered together. Okay, here's how it worked. First, you have the reference language. Think of this as the master blueprint. It's pure, it's perfect, it's the absolute source of truth. Then you have the publication language. This is the flexible one, the one that lets you use normal math symbols so it's easy for people to write and read. And finally, you have the hardware representations, which were just practical versions tailored to the clunky keyboards and printers they had back then. And here's where you see how clever that is. The super strict reference language might demand a specific kind of bracket for a subscript, but the publication language just says, hey, don't worry about it. Just write it the way you would in a math textbook. It was this amazing system that worked for both machines and people. That 3-language system? Super smart. But it's not even the biggest idea in this report. Not by a long shot. The real revolution, the thing that changed everything, was creating a formal, mathematical way to define the rules of a language itself. I love this. The author started this section with a quote from the philosopher Wittgenstein. And that tells you everything you need to know about their ambition. They weren't just listing rules. They were trying to build a system where you literally could not be ambiguous. If you could say it in ALGOL, you could say it clearly. Period. The name they gave it sounds pretty intense. Metalinguistic formula. But really, all it means is a language for describing language. It's a concept so powerful that today we just call it Backus-Naur form, or BNF, named after 2 of the guys on the committee, John Backus and Peter Naur. Okay, I know this looks like a cat walked across a keyboard, but trust me, this is the magic. This is an actual formula from the report. You don't need to get what every little symbol means. Just know that this was it. This was the aha moment, a precise rule for defining what's allowed in a language. Because with this notation, you suddenly had a recipe. Not for a cake, but for a language. A formal, mathematical recipe. This wasn't just a description of one language. It was a blueprint for how to build any language. I mean, what a total game changer. All right, so a bunch of abstract ideas from 1960. How does that connect to us scrolling on our phones today? Well, these concepts didn't just fade away. They became the absolute bedrock of modern computer science. So many things we just take for granted now were either invented or popularized by ALGOL 60. You've got block structure, which is just putting related code into neat little boxes. Lexical scoping, that's basically the what happens in Vegas stays in Vegas rule for code. Variables don't leak out and mess with other parts of the program. Type declarations, forcing you to be clear about your data, which stops a ton of bugs. And recursive procedures, which is this powerful idea of functions calling themselves to solve big problems. And if you want the smoking gun, the most direct proof of its influence, this is it. Look at this. On the left, ALGOL 60 used the words begin and end to group code. On the right? Yep, that's the curly brace, the symbol used by pretty much every major language today. It is a direct, undeniable family resemblance. So just let that sink in for a second. Every single time a developer types one of those curly braces, they're using a concept that was formalized back in 1960. That simple idea of a block is what makes it possible to build massive, complex software without it all falling apart. That is one heck of a legacy. Which kind of leaves you with this one big, fascinating question, right? The designers of ALGOL 60 came up with ideas so fundamental that they're still shaping our world over 60 years later. So what's being invented right now, maybe in some obscure research paper or a tiny open source project, that people in the year 2080 will see as the blueprint for their world?